grade 6 students, and welcome back to our science class. This is me again, teacher Ann, and for this unit 3, and we are now in lesson number 3, and we will be discussing about electrical energy sources. So what are some electrical energy sources? But before going there, we will review first our previous lesson. Okay, last time we talked about the electrical conductors and electrical insulators. Okay, so when we say conductors, so these are the materials that allows the flow of charge in one or more directions. So conductors are the materials that allow the electricity to current to pass through it. So the first conductor is we have the silver. So silver is the best conductor of electricity because it contains a higher number of movable atoms. Next to that we have copper. Second place is copper. And we have the third one, which is the gold. So, and in the fourth place we have aluminum. So aluminum is often used because of its lightweight materials that is cheaper than gold, copper, or silver. So that is number 4, aluminum. And now let's go to electrical insulator. Electrical insulators, so these are the materials that does not allow the electricity to flow. So we have here examples. We have rubber, we have cloth, we have glass, and we have wood, and the last one we have plastics. So these are examples of electrical insulators, meaning if you use these things, electricity will not work. Okay. So now let's go to electrical energy sources. So what are some electrical energy sources? Okay, the first here is we have the battery. Okay, we have the battery. We have two types of battery. We have the dry cell and we have the wet cell. Okay, cell battery. So dry cell batteries, they create electrical energy by converting chemical energy into electricity. So from the chemical energy from the battery, from the dry cell battery, so it will convert into from chemical, it will convert into electricity. So dry cell battery comprises or a zinc casing containing a conductive paste and a carbon rod inserted through the center of this battery. So that's it. We have dry cell batteries. So these are examples of the dry cell batteries. And we have also what we call the wet cell batteries. So when you say wet cell batteries, so is the original type of rechargeable battery. So they are rechargeable, you can recharge. So, and also the battery contains a liquid electrolyte such as sulfuric acid, a dangerous corrosive liquid. So that's why it's called a wet cell battery, because it contains a liquid. Okay, liquid, and it's very hazardous or health if this liquid will be poured out in the water. And since this wet cell battery is the most common example of this, is the battery of our very own cars. So that is wet cell batteries. Okay, next to that is we have generator. We have generator. So a generator consists of magnet and a coil of wire. So this is the source of the mechanical energy are various, such as turbine, wind, or water. So we can get a source of energy through that thing. The wind, it can be turbine, or it can be water. So the important principle of this generator, so it converts mechanical energy into electrical energy. That's why we can use it for electricity. So generators also, they produce electricity from home industry, contain large coils that rotate in a very strong magnetic fields to generate electric current. So most of the company or even some homes, they use generator, okay, for them to use electricity. So now let's talk about what is series and parallel circuits. Okay, let's find out what are these things. So first we have an open circuit. Okay, look at this. This is an open circuit, meaning it's not connected. This one, it's not connected. So in an open circuit, electricity current cannot flow, okay, because there is a break in electrical wiring. So the opening switch prevents electric current from flowing, so the bulb doesn't light up. So if this open circuit, meaning the electric current will not flow to the wire, so meaning the bulb will not light up. So we have also what we called closed circuit. Closed circuit, so it's closed. So a closed circuit is a complete electrical circuit with no breaks. The electric current can flow without interruption, so causing an electric light bulb to light up. So we have an open circuit, this one, and we have the closed circuit. So let's go now to series circuit. If we say a series circuit, it contains one path for electricity to travel through. So this is example of an electric circuit. So this is only one path of electricity. So it is only one way. So where the electricity travel through so that the light bulb will light up. So this is kind of a series circuit. So if a series circuit breaks in any place, the entire circuit stops working. So if somewhere will be break out, so meaning the whole bulb will not lighten up. So all of this bulb will be affected. So that's series circuit because they only have one wire, okay, or one path of electricity to light up these three bulbs. So we have also example if so now we are now in parallel circuit. So parallel circuit, it comprises branches so that the current divides and only part of it flows through any branch. So if unplug or turn off of electrical appliances, it will not work because there is no electric flow to the appliances. Of course, if you will plug it out, if you will plug it out from this socket, so of course the entire bulb will not work. Okay, look at this. So this is an examples of parallel circuit, which means example, okay, there are parallel circuits, so there are contains more than one path for electricity to travel through it. So we have wire in here, connect to this bulb, and we have another wire in here, connect to this bulb, and we have also one wire connect to this bulb. The only difference between the series and the parallel is that series, they only pass through in one path, but parallel, they have difference. So that's why if the one bulb is not working, so the other two bulbs will not be affected because they have different wire. So if one part of the circuit breaks, the rest of the circuit can keep working. Okay, and like for the series, if one circuit will break out, so all of the three bulbs will not work. But in parallel circuit, so because they have because each of them have this wire, so if one will break out, so the two will still work. Okay, let's have this one. So if there is an open switch along a path, electricity will not flow through that path. Okay, remember, if this wire will be break out, of course the electricity will not be connected, so the electricity will not flow to that path. All right, so that is very simple. Okay, now let's differentiate the the series circuit in the parallel circuit. Okay, in series circuit, it only pass through one path. Okay, this is a closed circuit, so look at this one. So it only flows, so this is the battery, so it only flows from one path. All right, so look at this one. Again, it only pass through, the electricity will only pass through one way or one path. But for the parallel circuit, look at this. So there is a way here, there is also a way here, so that's it. So they are different. So that's why if this this wire will be break out, but still it's work. Okay, so it's not a problem because this is the only way one will be affected but the other bulb will not. So that is the difference between the series circuit and the parallel circuit. Okay, let's take a look at this. So we have a battery connection, we have brightness of a light bulb. So let's see how bright is the light bulb. So if we have here, if we have a single battery, meaning it less bright because one battery shares two bulbs. So meaning the brightness of the bulb is not that very light. So it has a less bright. But if two batteries connected in a series, okay, look at this, and only one bulb will use it, so of course it's very light. The brightness of the light bulb is very bright. And what if the two batteries connected in a parallel? So what will happen? So example, we have here another bulb, so less bright equal to the brightness of a single battery. So it will again, it less bright equal to the brightness of a single battery. Okay, if this is less bright, so it will more, but this one is very bright because two batteries in one bulb. Okay, so this is your worksheet for today. So I will read you the directions, so you have to decide whether each of the circuit is a series or a parallel circuit, and then you have to circle your answer. Okay, if you can still remember, series is only one path of wire, but in parallel, so there's another wire connected to another light bulb. So I want you to circle for this one, number one. So try to circle, is it a series or a parallel circuit? For number two, the same, series or parallel? For number three, is it series or parallel? Okay, how about for number four, is it series or a parallel? And for number five, which type of connection makes in a brightest bulb. So this is in our last slide. So letter A, we have single battery. Letter B, 2 batteries connected in a series. C, 2 batteries connected in a parallel. So which of which is more brighter? So I hope you get something from this lesson, and I hope you will answer this one. This is only 5 items. So thank you for listening, and see you in our next video.